Okay, the concept of number and types of numbers. Number is an abstraction used to quantify objects. Numbers, we need numbers to solve problems and prove various theorems. And for that reason, we need to understand also what types of numbers are out there. The main types of numbers include natural numbers, whole numbers, rational numbers, real numbers. Okay, well, let's understand. Start with natural numbers. Natural numbers are the numbers obtained by natural counting of objects, like when I'm counting 1, 2, 3, 4. Those are natural numbers, or rather by their numbering, first, second, third, fourth. Okay? The set of natural numbers is denoted by letter N. This is notation of natural numbers. And natural numbers start from 1. There we go. 1, 2, 3, 4, and so on, 3 dots. So, the notation for natural numbers is 1, 2, 3, dot, dot, dot. So as you can see, 0 is not included in natural numbers because you don't count. When we count, we don't count from 0, 1. We count from 1, 2, 3, 4, 5. So natural numbers are the numbers that we count, we used to count. Dot, 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 meaning it's going to continue. And it's going to be only positive number. We don't count negatively, -1, -2, -3, right? Okay. Whole numbers, it's a different story. Whole numbers include the 0. Look here. Whole numbers include 0. All right. Next important numbers are integers. Integers are numbers that include all whole numbers and negative numbers, which means integer have notation of z, and they can be represented as a set of, okay, let me clean like that, z. And they can be represented as dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So all whole numbers, all numbers without fractions. So from negative numbers, including 0, and continuing to positive number. Okay? That's what we call integers. As you can see, integers include 0. Okay? All right. Next one, rational numbers. Rational numbers are the numbers we can represent in the format P over Q. Well, since it's a division, Q cannot be equal 0, obviously, right? Q cannot be equal 0. And P over Q, that's a fraction. So every number that can be represented in the format of fraction, we call rational numbers. Rational numbers, it's practically integers and plus, well, whole numbers. Integers, I would say, yeah, integers include already whole numbers already. So I can take off these integers plus whole numbers. 1 second. Okay, so any number you can represent as a fraction, it's gonna be rational numbers. So for example, I mark down here, if I have 4.0, it's the same thing, or 4, right? I can write down it's equal 4. Since as long as I can represent 4 over 1, right? That means it is rational. Next, 0.5, it's right here. I can write down 0.5, which is going to be equal, it's a 5 over 10, which is 1 over 2. It's a fraction. Everything that you can represent as a fraction, that's going to be a rational number. 6.57, that you can represent as a 6 and 57 over 100, also rational. Now, different story is if I have number, let's say 3.33, if it continues 3, then we put here at the line, that means it's this 3, it's going to continue. But you still can represent in the format of fraction, yes, 33 of 100, or if you have another 3, it will be 3.333 over 1000. As long as you can represent in the format of fraction, you have rational numbers. Okay. Next, irrational number. Irrational numbers are the ones that have type of square root and it's not clean comes out. Let's say square root 4, it's gonna be 2, right? Which means it can be a rational number and it can be as a natural number and it can be whole number, which is part of integers also. But it's a different story. 1.3. 1.3 has entire chain of numbers that are not repeating. So when they are numbers that are keep continuing and do not repeat, that means we cannot represent them in the format of fraction. That's what we call irrational number. Let's say if we take also pi. Pi also it's the equal 3.147 blah 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 blah. Numbers do not repeat. Therefore, you cannot represent them in the format of fraction, which means it's also irrational number. Same way the letter E, which is widely used in math, or logarithm. Okay? And lastly, real numbers. Real numbers are those rational and irrational. All numbers, practically all numbers together, is accepted as real numbers. And let me show you how we can represent in the format any types of numbers we have. Let's assume we want to say all natural numbers. So we have, I already showed, but it doesn't hurt to repeat. We have in set, those are curly braces, and 1, 2, 3 dots meaning continuation. Let me put 3 dots. 1, 2, 3. It's accepted to put 3 dots. So, yeah, 1, 2, 3. So 1, 2, 3. Okay. Now, what if I mean to say only 1, 2, and 3, and that's it? Then I'm going to show this way. Or I want to show numbers, let's say 5, 10, and 15. So I'm going to put the same way, 5, 10, and 15. Doesn't matter. Okay? Doesn't have to be in sequence 1, 2, 3, 4. Next, what if I want to represent rational numbers? Here we have rational numbers, which we have 3 dots, meaning it doesn't start from -2, it starts from even negative infinity, which can be -999, -998, -997, right? So, or -3, -2, then continues with 0. We just show pattern. As long as you make clear what the pattern is, that's all that matters. So when you have 3 dots in front of -2, we know it will continue in the negative area. And then we have +1, 2, and there is no limit how many numbers you want to put. As many as you feel you are expressing clear pattern. If you would put 0, only 1, well, it's kind of not precisely clear, but 1, 0, 1, 2, or 0, 1, 2, even 3, you can add. That will already clearly show 1, 2, 3. It will show the pattern, so it keep going. Or you can show the pattern in the also following way. If you go by 2, let's say -6, -4, -2, 0, 2, 4, 6, and you continue 3 dots. It's a good habit if you show 3 numbers to the left from 0. It's a good habit from the left. So it's a good habit to put also 3 numbers to the right. Okay? And lastly, this means it's empty set. There are no numbers whatsoever. Its set is empty. Okay, this is kind of basic understanding of numbers, and hopefully this will help. Next video I'm going to make decimal notations, how to convert fractions to decimal notation, and then operations with decimal notations will go. Okay, thank you for watching. See you next time.